morning, class. Everybody, please stand up. Let's make the sign of the cross in the name of the Father, the Son, the Holy Spirit. Amen. Once again, class, good morning. Before you take your seats, kindly pick up pieces of papers on the floor and throw it in the trash bin. And also, please arrange your chair properly. Okay, class, you may now take your seats. Before anything else, let me check your attendance. Say present if your name is called. So, very good, class. All of you are present today. Before we talk about splitting up fractions, let's review how to combine fractions. You have been doing this since elementary schools. To add fractions, we need a common denominator. For example, 2/3 plus 2/5 plus 7/3 is equal to 41/8. Notice how we multiply the top and bottom to each fraction in order to get equivalent fractions involving fractions with the same common denominator. The same procedure works on functions involving fractions. For example, f of x is equal to 1/x minus 2 plus 3/x minus 5 is equal to 41x minus 11 over open close parenthesis x minus 2 open close parenthesis x minus 5. So another example is g of x is equal to x over x squared plus 4 plus 2 over x plus 3 is equal to 3x squared plus 3x plus 8 over open close parenthesis x squared plus 4 open close parenthesis x plus 3. Do you understand, class? Are you sure?
Yes, ma'am.
Very good. Before anything else, I would like to expect that you will be able to define partial fractions, identify the different cases of partial fractions, and third is decompose fractions into partial fractions. What do you think of our objective, class? Is it achievable? Very good. Okay, class, let's go back to our topic. What is partial fraction? Anyone have idea about partial fraction? Very good. A partial fraction is a rational function nx over dx where the degree of nx is less than the degree of dx. Can be expressed as a sum of two or more simple fractions. Okay, class? Do you understand what is partial fraction? Very good. Take note, class, that if a rational function nx over dx is an improper fraction, that is, the degree of nx is greater than or equal to the degree of dx, divide nx by dx until a proper fraction is obtained. So, the denominator of the partial fractions are obtained by expressing dx into a product of linear or a quadratic factor. So the methods of determining the partial fractions depends on the nature of factors of dx. This leads to the any cases as follows. There are four cases. First is distinct linear factors. Second is repeated linear factors. Third is distinct quadratic factor. And lastly is repeated quadratic factors. The methods of determining the partial fractions depend on the nature of factors of dx. This leads to any cases as follows. Distinct linear factors. Second, repeated linear factors. Third, distinct quadratic factors. And lastly, repeated quadratic factors. Class, did you understand?
Yes, ma'am.
Okay, let's continue with our discussions. So everybody, please read distinct linear factors. A Again, distinct linear factors of a form ax plus b found in dx, their correspond are partial fractions of the form a over ax plus b when a is the constant to be determined. For example, class, 2x plus 3 over open close parenthesis x plus 2 open close parenthesis 2x plus 3 is equal to a over x plus 2 plus b over 2x minus 3. So another example is x to the power of 4 plus 3x to the power of 2 plus 1 over x to the power of 3 minus x. So it's equal to x plus a to the power of a over x plus b x plus 1 plus c x minus 1. So clear, class? No questions?
Yes, ma'am.
So let's proceed to repeated linear factors. All boys, please read repeated linear factors. Okay. Repeated linear factors is for every factors ax plus b repeated n times found in the dx. There corresponds n partial fractions of the form a1 over ax plus b plus a2 over open close parenthesis ax plus b squared plus a to the power a3 is equal to open close parenthesis ax plus b to the power of 3 plus dot 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 plus an over ax plus b open close parenthesis to the power of n. So let's have an example class to help you understand. X plus 2 over 3x minus 1 open close parenthesis to the power of 3 is equal to 1 over 3x minus 1 plus b over 3x minus 1 open close parenthesis to the power of 2 plus c over 3x minus 1 open close parenthesis to the power of 3. Understand, class?
Yes, ma'am.
So let's have another example. X to the power of 3 plus minus x plus 2 over x plus 2 open close parenthesis x plus 3 open close parenthesis to the power of 2 is equal to a over x plus b over x plus 2 plus c over x plus 3 plus d over x plus 3 open close parenthesis to the power of 2. Okay, class? Let's proceed to distinct quadratic factors. All girls, please read distinct quadratic factors. Okay, distinct quadratic factors. For every distinct quadratic factors, the form ax squared plus bx found in dx, there corresponds a partial fractions of the form ax plus b over ax squared plus bx plus c, where a and b are constant to be determined, and b to the power of 2 minus 4ac less than 0. So, for example, class, let's have example. Just wait. Example is x squared plus 2x minus 1 over 2x x squared plus 2 open close parenthesis x squared minus x plus 4 open close parenthesis is equal to ax plus b over x squared plus 2 plus cx plus d over x squared minus x plus 4. So, one more example. X squared plus x x plus 5. Understand, class?
Yes, ma'am.
Okay. Let's proceed to repeated quadratic factors. Anyone in the class have the idea what is repeated quadratic factors? Very good. Please read quadratic and repeated quadratic factors. Thank you, class. For every quadratic factors, non-favorable ax squared plus bx plus c, repeated n times found in the dx. There correspond n partial fractions of the form a1x plus b1 over ax squared plus bx plus c plus a2x plus b2 over ax squared plus bx plus c open close parenthesis squared plus a3x plus b3 is equal to ax squared plus bx plus c open close parenthesis to the power of 3 plus dot plus anx plus bn over ax squared plus bx plus c open close parenthesis n, where a and b are constant to be determined, b to the power of 2 minus 4ac less than 0. Clear, class?
Yes, ma'am.
So let's have example. X to the power of 3 minus 2 is equal to ax plus b over x squared minus 3x plus 9 plus cx plus d over x squared minus 3 plus 9 open close parenthesis to the power of 2 plus ex plus f over x squared minus 3x plus 9 open close parenthesis to the power of 3. So one more example is x plus 1 over x squared open close parenthesis x plus 3 open close parenthesis x squared plus 1 to the power of 2 is equal to a over x plus b over x squared plus c over x plus 3 plus dx plus e over x squared plus 1 plus fx plus j over x squared plus 1 open close parenthesis to the power of 2. Understood, class?
Yes, ma'am.
Is there any questions or clarifications regarding our discussions? Okay, class. Class, let's proceed to the determination of constant in the partial fractions. There are two ways to find the constant of the partial fractions. Namely, by assigning values to the variable. This method uses a concept that if two polynomials are identical, then they are equal for any value assigned to the variable. The most convenient values are those that will make the denominator to the given rational function 0. So second is by equating like powers of the variable. These methods uses the concept that if two polynomials are identical, then the coefficient of the power of the variable in one polynomial is equal to the corresponding coefficient in the other polynomial. And if that's so, we'll be having a short quiz. Please get 1 half sheet of paper and answer the following. Are you done, class? Okay, so pass your paper to the person in front of you. Now, I want to know or test you if you really understood our topic. Yuri, what is partial fractions? Very good. Next is, what is the difference among distinct linear factors, repeated linear factors, distinct quadratic factors, and repeated quadratic factors? Anyone in the class? Yes. Very good. Next is, what is the two ways to find constant in the partial fractions? Yes, Jane? Excellent, class. I think you already understood our topic for today. So for now, get 1 whole sheet of paper and answer the following. Now, you are given 5 minutes to answer. Okay, class, pass your papers. In the count of 5. 1, 2, 3, 4, 5. Now class, kindly get your notebook and write this as your assignment. Search and study in advance about polar functions. Are you done copying, class? Okay. Okay class, keep your things and pick up pieces of papers on the floor before leaving. Goodbye class. See you around.